All right, here we're looking at our notes for section 5.4, and really we're going to be solving these radical equations. So that's really our only learning target for today, is I can solve equations containing radicals. So the sheet that you're going to need looks like this on one side, and just kind of like this on the other side, and we're going to go through these different scenarios together. So when we're solving an equation, right, an equation means I've got an equal sign, and solving it means I'm going to get x by itself. So to solve it, I have to undo everything that's being done. So the first thing is I have to make sure that that radical is all by itself before I can do anything else to it. So here I see that I'm multiplying by 2. So to undo that, I go ahead and I divide both sides by 2. So I end up with the square root of x plus 1 equals, and 4 divided by 2 is 2. Well, now that my radical is all by itself, so now I can undo that. So to undo a square root, I would square it. And I have to do that to both sides. So then here I end up with x plus 1, because the square root and the squared get rid of each other, equals 2 times 2 is 4. Then this is just a simple linear equation. So to get that x by itself, I would subtract 1 from both sides. So I have x equals 3. So the one thing I have to do, and you have to do this when we're dealing with radicals, is actually go back and double check that it works. So here when I plug 3 back in, I end up with 3 plus 1 inside my radical, which gives me 4. I know the square root of 4 is 2. 2 times 2 is 4. So that one works out just fine. Okay, so I know that one works. So now let's look at our next example. Okay, so this is a little bit more complicated. So I've got several things on the other side rather than my radical. But the first thing I do notice is that my radical is by itself. So I can go ahead and undo that by squaring. Okay, so I square the side. One thing I want you to be really careful of is when we square this, it does not just become x squared plus 1. You cannot just distribute this exponent. You have to actually multiply it out. So this becomes x plus 1 times x plus 1 equals 7x plus 15. Okay, so I have to actually multiply that out, which ends up being x squared plus 2x plus 1 equals 7x plus 15. So that, now we're going to end up with a quadratic, right, because I have an x squared. So I want to go ahead and get everything over to one side of my equal sign. And I like to get it over to where my x squared is, just to kind of keep things simple. So I am going to subtract my 7x. So I end up with x squared minus 5x plus 1 equals 15. So then I subtract my 15. So x squared minus 5x minus 14 equals 0. So when I have this quadratic, I first want to try and factor it and see if that'll work. And if it doesn't factor nicely, then I can use either the quadratic formula or some other method. But in this case, I'm going to try and factor it first. Okay, so I come up with all of my factors of a negative 14, which would be a negative 1 and a positive 14, or a 1 and a negative 14. 2 and a negative 7, or negative 2 and a positive 7. So this would give me 13, negative 5, and 5. Well, here I end up with this negative 5, and that's exactly what I wanted. So I can factor this one. So this becomes x plus 2 times x minus 7 equals 0. So then I set each of these pieces equal to 0 to get my final answers. So I subtract 2, so x equals negative 2, and I add 7. So then x equals 7. So I have to go through and to double check these. Okay, so let's go ahead and start with this negative 2. So if I put this negative 2 back in, up here in my original equation, I will end up with a negative 2 plus 1, which gives me a negative 1 over here. And then a negative 2 in here would give me a negative 14 plus 15, which would give me the square root of 1. Well, I know that that doesn't work. The square root of 1 cannot be a negative number. So I know that this answer does not work. So that's not a possible answer. This is what we call an extraneous solution. And an extraneous solution is we've gone through it and we've actually solved, but it's something that doesn't actually work. Okay? So that's kind of important with these radicals, is we do have to go in and double check. If we take the 7 back in, it will eventually work. Okay, so let's get a little bit more complicated. We're just going to keep adding a little complexity every problem. So here you see I have two radicals. Okay, so I can't get one radical all by itself, or the other one has something with it, and that's okay. We just have to do several different, add another layer of steps. So I see I have one radical by itself, so we're going to go ahead and square everything. Okay? We have to square both sides, not just the pieces, but the actual sides. So this right side actually simplifies to then be 3 minus x, which is lovely. This side becomes a little bit more complicated, because remember, I can't just distribute this. It becomes the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. So then when I simplify that out, when I multiply these two together, I end up with x plus 2. Then I end up with 2 of these, plus 2 square root of x plus 2's. 1 times 1 is 1, equals that 3 minus x. So I see I'm not quite to a place where I can continue to really simplify it yet. I still have a radical in my equation that I have to get rid of. So let's do everything else to the other side and then deal with that radical. Okay, so here I see on this left side I end up with x plus 3, because I'm going to combine these two terms, plus 2 times the square root of x plus 2 equals 3 minus x. Well, let's go ahead and subtract this 3 from both sides, so it goes away, and I'm going to subtract an x from both sides. So now I have 2 times the square root of x plus 2 equals a negative 2x. So the next thing I have to do before I can square anything is I have to get rid of this 2. So I undo that by dividing by 2. So now I have the square root of x plus 2 equals a negative x. Well, now I'm left with just a radical on this side. So now is where I can again go ahead and square it. And I got to be careful with my parentheses. So now on my left side I end up with x plus 2. I know a negative x squared becomes x squared. So now again I have a quadratic. So I get everything to one side, and I'm going to move things this way this time because that's where my x squared is. And go from there. So we subtract an x and subtract a 2. So I end up with 0 equals x squared minus x minus 2. Let's see if we can factor this one. All of my possible factors of a negative 2 are 2 and a negative 1, or a negative 2 and a positive 1. This gives me a positive 1, this gives me a negative 1. Here's what I need. So I can go ahead and say x minus 2 and x plus 1 equals 0. I set them both equal to 0, so I end up with x equals 2 or x equals a negative 1. And just like we did in this last example down here, I have to plug both of these in to make sure that they work. And when I do that, and I'm going to let you do this so you can show how it actually works. When I plug these back in, I see that my x equals 2 does not work. So that would be considered an extraneous solution. So this is my only real solution for this one. Okay. So now let's look at an inequality, right? That just tells me it's not equal. There's one extra step when we have to deal with this. So first of all, we're just going to solve it as if this was an equal sign, following all the rules for just a normal inequality. Okay. So first I see I have to divide by 3. So I end up with the square root of x minus 1 is less than or equal to 4. Again, this is all by itself, so now I can go ahead and square both sides. So x minus 1 is less than or equal to 16. Then I add 1 to both sides, so x needs to be less than or equal to 16. So the other step when we're dealing with this inequality is we have to deal with what's underneath the radical. So I know that I'm not going to be dealing with any imaginary solutions here, only real solutions. So I take everything that's under the radical. So I take all of this stuff, this x minus 1, and I set that greater than or equal to 0. And this greater than or equal to 0 is always going to be the same, because we're not going to be dealing with any negatives, because those negatives would give us those imaginary numbers. So we always take what's underneath the radical and set it greater than or equal to 0. Well, so then I can just add 1 to both sides, so x is greater than or equal to 0, or to 1. So now I can combine these two, and I'm sorry, this is a 17 once we add that 1. So now I combine these, so I know that x is in between these two values. So 1 is the smallest it can ever be, but 17 is the biggest it can ever be. So then here would be my final solution for this inequality. Okay, so the big thing to remember from this section, right, is that we have to get that radical all by itself before I can actually square it and try and get rid of it. If I've got two radicals, I get one by itself, and then I have to go through the process more than once. If I'm dealing with an inequality, I always also have to add in the stuff underneath the radical sign has to be greater than or equal to 0, or else we're dealing with imaginary numbers, and that's not what we're doing here. So how I want you to fold this is you'll see that if I fold these in, okay, we're going to make a little cheat sheet here. Okay, so now what we can do is, let me find my scissors. We're going to cut along, and these ones didn't line up perfectly, so we're going to cut a little bit in the middle of each side. So now when I tape this or glue this into my notebook on the next page, I see, oh, I have an extraneous solution. What does that look like? And I can open up my tab and see everything that we just did. Oh, here's a radical, just a plain radical inequality. And we can kind of figure out what that looks like, okay? And these may or may not match up all that well right now, because they don't seem to be. But this is just kind of our example, and we can just fold out and look and see what we've done. So as always, remember to come to me when you get stuck, or shoot me a quick email.